So let's continue in this question. Hopefully you worked out from here on. So from there on, well, where would it go? So here's your first integral with respect to u, right? So you're picking this to be like w, and you still got to do your you're treating v like a constant, and you still got to pick this to you say like w equals that. So you say like let w be u over v, and then you got to do dw. So 1 over v du. And so the v will comes up to here. So you end up getting this as your v. Anyway, so check that out. That's how it's worked out. Okay, and then you do your next integral and simplify, and you get something like this. And you can simplify that further if you want. All right, let's look at the next one. Evaluate the double integral e to the x squared y squared. So, and then the region, this is the region that's given. So your region is given like this in the xy plane. Okay, so this is your xy plane here. And then you convert it to the r theta plane. So this one's a little different in that you already know what the substitution is in the transformation. You already know that x is in terms of r theta and y is in terms of r theta like this. So you know this transformation already. Still got to calculate your partials, but you don't have to solve. So you're not like picking u to be that or anything. So this shows again why you get that extra little factor of r in there. Okay, so this is your sector, right? And then you already know the transformation. Then you do your partials, cosine, right? So check out all your partials that you get. When you do your Jacobian and do the products, you get this form, which is just r. So in your integration, you get this, and here's your little extra factor of r, which we already know how to do that. We've done that before. Now your transformation, you're going into the r theta plane, and it becomes just a rectangular region. So when you have that rectangular region, it's much easier. It's just going, r goes from 1 to 2, and theta 0 to pi halves, and it ends up being just, it's not like a sector like this. And so, so finish that and see if this works. And then you evaluate. I don't have the solution handy here. So evaluate this with respect to r, and it's pretty straightforward from there. Okay, so try this next one. This one will take a little while to do. So evaluate e to the xy over x plus y, where r is bounded by these graphs. So y equals x plus 5 is here. Y equals 2 minus x is this one. Y equals 4 minus x is this one. And so you'll need to figure out the intersection points. And this is your region R that you start with in the xy plane. So then you got to solve for u and v. So you pick your u and your v and solve, and then you got to write in terms of the other variables. Okay, so try that. I don't want to go on yet, so try that. There's a lot of things to do here, but it's all here, so I'll just kind of go through it as you pause it and try it. So you want to find all your values in your intersection points, okay? And write u in terms of xy and v in terms of xy. Okay, once you've done your substitution there. Okay, so when you do that, you get, here's your points, and then you solve and get your points for your UV and you plot them. And then you got to decide how you're going to integrate over that. So you would continue. From there, you can calculate partial x, partial y's. Okay, so see, where is it? So partial x respect to u. So you got to here they are. Here's where we solved it here. So this is just like before, right? X is 1/2 u plus v. Y is negative 1/2 u minus v. Okay, so it's pretty much the same as before. And you get your Jacobian to be 1/2. And then you're going to integrate over this region. Okay, so spend some time on this one to work it out, and you work all this out and you get this form. This one would normally take, this was a good 15 minutes or more of work to go through all these steps. So look at the steps again. Let's go back. Okay, so you have your region that you have to draw. You have your choice of u and v, pretty much going to be obvious. And I usually tell you because otherwise it could change the regions and it's much more difficult to look at or grade. Then you need to solve for your intersection points in this case. And then take your transformation and plot your points in the UV plane. Okay, then you got to do your Jacobian using partial x, partial y's. You calculate your Jacobian to get and that could be a variable in there. In most cases, we're just going to have constants, but it could end up being a variable. All right, so you solve for x in terms of uv, y in terms of uv, and then you're going to integrate around the new region of u and v. This was r, but now this is the new region. And in this case, it's kind of nice because it's just a rectangle. Okay, and then you do your Jacobian, don't forget absolute values, and then you evaluate.